what we've got here is, it's asked us, we've got a function here. We want to find the derivative of the function at x equals 2. So if we have a look at this function, we could expand it, but time to use the product rule. So with the product rule, we're looking at the product of two functions. What we're going to do is we're going to differentiate them both. We're going to identify the functions, individual functions, differentiate them both, and then substitute them into this formula here. So here we've got u equals 4x, v equals 2 minus 3x, du will equal 4, dv equals negative 3, and now we substitute into that. So we've got 2 minus 3x being multiplied by 4 plus negative 3, which is dv, multiply that by u, which is 4x. So from there, now that we've got it into that form, all we need to do is just substitute x equals negative 2 in there. We can expand, we can simplify things like that, but I'm not going to, I'm just going to substitute that in there. So we've got 2 minus 3 negative 2, well, that gets multiplied by 4, plus negative 3, 4, negative 2. So over here we've got negative 6, so saying 2 plus 6 gives us 8, multiplied by 4 gives us 32, plus 4 times negative 2 is negative 8, multiply that by negative 3, we end up with 24, so we end up with 56. So to effectively use the product rule, look at your function, your overall function, divide it into your two functions, u and v. Write them down, write down what u and v are. Differentiate u and v for du dx and dv dx. Then substitute into the original, substitute into the product rule function. And then from there, you'll find the derivative. If you're asked to evaluate it at a point, you stick that point in instead of 2. If you're asked to find out where the derivative equals something, or the gradient equals something, well then you let the derivative equal that. Sometimes simplify it, but other times it's just a step that you don't necessarily need.